Permutation combination, lecture number 6, case 7, code generation. Since we started off permutation combination from case number 1, the videos are easily gottable in the YouTube channel. You can easily get them. Permutation combination, lecture 1, where we started off with arrangement selection. We went with non-repeated alphabet in case number 1. Then in case number 2, we made sure that we go with simple selection with 1 president, 2 assistant, and 8 members. With case number 3, we had 6 men and 4 women. That was team member selection. Then we had case number 4, that was complicated seating arrangement. Case number 5 was application of arrangements. Case number 6 was repeated letter arrangement that we did in the last class. Now, lecture number 6 with case number 7, where you need to understand that, let's say that where do we have code generation? When we have that ATM pin codes, pin codes or normal safe codes or codes for anything, any particular gadget, that is called code generation. Even your phone codes are one of them. So ATM pin codes can involve, let's say no digit is repeated. You already know in ATM pin code there are 4 numbers. How many numbers do we have? We have 4 numbers in total. So no digit is repeated. So what does that mean? That means if we can have 10C4 into 4 factorial, which means 5040. Or we can have 4 digits, 10C1. When one number is here, then obviously that number cannot come again. So then that means it will be 9C1. Then if that number is there, and obviously those 2 numbers cannot come, so it will be 8C1 and this should be 7C1. So this is normally allowed for what? 10 into 9 into 8 into 7. And this will again be what? 5040. This is when no digit is repeated, and you must be very careful in this. When we say no digit is repeating, you have digit that will start from 0 and will end till normally 9. So we have in total of 10 digits. Now, if I just say that repetition of digits are allowed, digits is allowed. Now, since we know that repetition is allowed, so 1, 2, 3, 4. That means for the first blank, we will be having how many possibilities? 10 possibilities. And out of that 10 possibilities, we can only have 1. In the second blank, we can again have what? 1 out of 10. In the third, even we can have 1 out of 10. And even in 4, we can have 1 out of 10. So that means 10C1, 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 10C1. 10 into 10 into 10 into 10, which can also reflect 10 to the power 4. So this means 10,000 possibilities. Now, what is the normal difference between the digit not being repeated and digit repeated? You need to understand, when digits were not repeated, at this point of time when you have 10C4, 10C4 means each time you are taking separate numbers. Each time you are taking separate number. Even when you have 10C1, 9C1, 8C1, 7C1, that means you are taking separate numbers and it is not being repeated. You might end up having 2 same numbers if there are any options, but at the moment we are talking about digits, and digits start from 0 to 9. So how many numbers do we have? We have 10 numbers in total. When digits are repeated, that means 10C1, 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 which means your code can be 3333. Your code can also be 4444. Your code can be 2222. But in this case, when digits are not repeated, if you have 2 in the first place, you can't have 2 again. If you have 3 at the first place, you can't have 3 again, because the digits are not being repeated again. Similarly, if we just move forward with the same concept, let's say, since we are working on the code generation, let's say we need to have passwords. We need to work on what? Passwords. And 6 alphabet passwords. Now, in total, we need to know that we have in total of 26 alphabets. In total, we have 26 alphabets. So, you can have number one, the question can be no repetition is allowed. No repetition is allowed. When there is no repetition allowed, that means each alphabet will be different. That means each alphabet will be different from each other. So, and obviously from A to Z, you have all the alphabet that are different from each other. So, what we can have is 26C6 into 6 factorial. 26C6. Out of the 26 alphabet, we'll be selecting 6 alphabets, and then for the movement, we'll be using 6 factorial. This will end up having what? 165765600. Or what we can do is we can work up with 6 different blanks, and we start off with 26C1. So when the first alphabet is here, then we'll go to 25C1, then we'll go to 24C1, 23C1, 22C1, and 21C1. So this is going to be 26, 25 into 24 into 23 into 22 into 21. So that particularly means that each time what I'm trying to do is, I'm selecting my first alphabet from 26 alphabet, second alphabet from 25 alphabet, third alphabet from 24 alphabet, fourth alphabet from 23 alphabet, your fifth alphabet from 22nd alphabet, your sixth alphabet from 21 alphabet. And each time what you are doing is you are selecting one out of 26, 25, 24, 23, 22, 21. So 26, 25, 24, 23, 22, 21, when the repetition is not allowed, So we will end up having the same answer, and the answer is what? 165 765 600. If the same question is says and it clearly identifies as repetition is allowed, if the question says repetition is allowed. Now what does this mean? This means that with 6 alphabet, I can have the repetition of the alphabet as well. So you can't have 26C6 now. Okay, 26C6 represents different alphabets. So you will be having what? 26C1, again 26C1, again 26C1, 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 and 26C1. So this is going to be 26 to the power 6, which is 308915776. So this is when the password is used with the respect to the alphabet. If repetition is allowed, you will end up having what? 26C6 into 6 factorial, or 26C1, 25C1, 24C1, 23C1, 22C1, and 21C1. And when the repetition is allowed, we can always say 26C1, 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 26C1 for the 6th alphabet password. Let's work on bike number plate, where we know one thing, that in bike we used to have one alphabet and 4 digits. One alphabet and 4 digit. If I want to have one alphabet and 4 digit, knowing the fact that the number can be again and again used, so this should be 26C1 into 10C1, 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 10C1. So this is going to be 26 into 10 to the power 4. So this is 26 into 10 to the power 4, which is what? 2, 6, 1, 2, 3, 4. Similarly, if we just say that we have two alphabets and three digits. So since obviously the code will have the repetition again. So this is 26C1 into 26C1 into 10C1 into 10C1 into 10C1, because the repetitions are allowed. So this should be 26 to the power 2 into 10 to the power 3. So the answer would be 7676000. Then we can also have three alphabets and three-digit numbers. So can we just say three alphabets and three-digit numbers? What does it mean? 26C1, 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 because the number would be repeated, alphabets will be repeated, as well as the number 10C1, 10C1, and 10C1. So this is 26 to the power 3 into 10 to the power 3, which means 1757600 will be the code or the number that we can get. So this is the code generation. If we just work upon the PIN, password, or bike number plate, even the car number plate can be another example of such codes that can be generation. That means with three alphabets and three digits, we can make up to 1757600 codes. With two alphabets and three digits, we can make up to 67600 codes. With one alphabet and four digits, we can make up to 260,000 codes. With six alphabets, with no repetition is allowed, we can make 165765600 codes with passwords. Repetition allowed, we can obviously have more passwords then. Similarly, ATM, when no digit is repeated, we can have 5040 different options. Repetition of digit is allowed, we can have 10,000 different options in this. Okay, moving further, let's take an example of different words that we can have. Let's say we have the word advance. So the question can be, find the number of arrangement without any restriction. Now, with this, expect that 1, 2, 3, 4, 5, 6, 7. We have 7 alphabets. Since we need to have number of arrangement, for 7 alphabet, we can use 7 factorial to have the arrangements for the alphabets. Because whenever we use arrangement, we use factorial. So we have 1, 2, 3, 4, 5, 6, 7. 7 alphabet, we'll be using 7 factor. But if you see, there are two A's being repeated. So when there are two A's being repeated, to finish the repetition of the numbers, what we'll do is we'll divide it by 2 factorial. So if I just write it down, the answer for find the arrangement without any restriction will be 7 factorial for the movement and 2 factorial for the obviously removing the same type of names that are being there. So the answer for this is 2520. Similarly, if the question is find the number of 4 alphabet code, 4 alphabet code using neither of A's from letters of the word advance. Now you need to make what 4-digit code, but Now you need to understand that A will not be used. Neither of A. That means A are cancelled. So how many numbers do we have? 1, 2, 3, 4, 5. Now in total we have 5 numbers left. In total we have 5 numbers left. So if we know that our 5 numbers are left and we need to make 4-digit 4 alphabet code. We need to have 4 alphabet code. So each code is very different from each other. That means each alphabet is different. D, A, N, C, E. And we need to make 4-digit code 1, 2, 3, 4. So what we're going to do is we'll be using 5C4 into 4 factorial. Because each alphabet is different. Considering this, we can also use 5C1, 4C1, 5C1, 4C1, 3C1, and 2C1. So the answer would be 5C1 into 4C1 into 3C1 into what? 2C1. Then again we have the answer of what? 120. And next part, if I just say repetition is allowed. Normally, if I have different alphabet, repetition is not allowed. So if I just say repetition is allowed. So if repetition is allowed, how many alphabets do we have? 1, 2, 3, 4. We need to find 4 alphabet code, but we are left with 5 alphabets. So this should be 5C1, 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 and 5C1 again, which means 5 to the power 4, which is 625. So this is when the question clearly mentions that you need to use the word advanced, but other than the 2 A's. That means 2 A's are not used. When 2 A's are not used, how many numbers do we have? How many alphabets do we have? 1, 2, 3, 4, 5. We have 5. When repetition is not allowed, we can have 5C1, 4C1, 3C1, and 2C1, or 5C4 into 4 factorial. When repetition is allowed, it would be 5C1, 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 and 5C1 again. So this is when the question clearly tells me about my word. Clearly, if the question says in part 3, if the question says number of whole letter codes using both A's remaining alphabets cannot be repeated. So the remaining alphabets cannot be repeated. So what does this mean? 1, 2, 3, 4. Now we know that 2 A's can be used. Let's have 2 A's. And we know that the remaining alphabets cannot be used. So that means alphabets cannot be repeated. Considering that alphabets cannot be repeated, so that means we will have 5C2. 5C2, and then movement of the 4 alphabets, that will give me 4 factorial upon 2 factorial because of 2 repetition of A. So this means 5C2 into 4 factorial upon 2 factorial. This 5C2 is for selecting 2 alphabet from remaining alphabet. Do you agree? Then this 4 factorial is for movement of 4 alphabet. That means you are arranging them. This 2 factorial is for removing the same code because of the 2 factorial, because of 2 A's. So 5C2 into 4 factorial upon 2 factorial. Or this can also be directly towards using what? 5C2, considering that these 2 alphabet will be moved, divided by 2 factorial multiplied by 4 factorial. So initially you can have any way possible as you like, but majorly it is 5C2 into 4 factorial upon 2 factorial. Okay, ji. So here we have another example question. The word says Tokyo. Find the number of three alphabet code using the letter of the word Tokyo. Now we need to understand that in this word, there are two O's that are being repeated. And if we consider this, we can always consider that we are making a code, and the code is of three alphabet. In those three alphabet, there can be options, and there can be three options. Option number one, there is no O. Option number two, there is one O. And option number three, two O's possibility. So that means there can be code with no O, there can be code with one O, and there can be code with two O's. So if I just work on the possibilities only, let's say that there is no O, possibility number one. Since there is no O, so 1, 2, 3. Out of 5 alphabet, when two O's are taken out, we are left with only three alphabets. So we need to have 3 into 3 factorial. The remaining 3 alphabet will be chosen directly because all the 3 alphabets will be chosen and those will be arranged as well. And then you will have the code with no O. The second thing is you will have one O. So let's take one O, but then again you will have two different alphabets as well out of 3. So this should be 3C2 into 3 factorial because obviously O will be moved. And the third, considering there are two O's, that means in the third alphabet you will have one option out of 3, but you will move 3 options but divided by 2 factorial as well. Why did I divide by 2 factorial? Because the question have this code generation in the third phase has how many O's it has? 2 O's. So considering that the question has 2 O's, so we assume that the question will be using 2 O's in the third option. So let's just say that we have in the first, second, and third, we have 6 options, 3C3 into 3 factorial. Then we have 18 options, and then we have 9 options. The total is 33 ways of having code using the word Tokyo because in the first phase there is no O, in the second phase there is one O, in the third phase there are two O's. When there is no O, so obviously it would be 3C3 into 3 factorial. It would be 3C3 into 3C3 into 3 factorial because out of Tokyo, since two O's are cancelled out, we are left with 3 alphabet. Out of 3, we are getting 3. In the second option, we know that O is coming, one O is coming. But out of the 3 alphabets, there can be 2 possible things, and this 3 alphabets will move. And obviously, since we have only one O, we will not be dividing. In the third alphabet, in the third code, there are 2 O's. In the third alphabet, we will have 3C1 into 3 factorial upon 2 factorial for 2 O's together. So this is how we will be creating code when we have repetitive alphabets given in the word or number. Example number 3, assume now again, we know that we have 2S here, find the number of 5-letter alphabet code word. So we will have to understand that there can be no S, there can be one S or there can be two S in the 5-letter code word. So if there is no S, so that means out of the 7 alphabet, it should be 5C5 into 5 factorial. If there is one S that is there, then 5C4 into 5 factorial. If there are two S, then 5C3 into 5 factorial upon 2 factorial will be used. So that means this should be 120, 600 and 600, which is 1320. You need to be very clear that in the 5 alphabet code word, you need to understand that here you have one S, here you have two S. So here you have no S. Out of the 7, there should be 5C5 into 5 factorial. Since you need 4 alphabet, 5C4 into 5 factorial. Here you have 3, 5C3 into 5 factorial, since 2s are there, upon 2 factorial. Repetition of 2s. So we will be taking down the values such as 120, 600, 600, which will give me the total of 1320. The question is clear now. The question is the same code generation with the word business form a 5-letter code word. Now we know that 3 S are being repeated. So the code can be with no S, with 1S, with 2S, and with 3S. If the code is with no S, so we need to understand that obviously 1, 2, 3, 4, 5. Out of 5, we will have 5C5 into 5 factorial. Then here we can have 5C4 into 5 factorial. Here we will have 5C3 into 5 factorial upon 2 factorial. Here we will have 5C2 into 5 factorial upon 3 factorial. Considering the fact that 1, 2, 3, considering the fact that we know that we will have 5 alphabets and no S means 5C5 into 5 factorial, every alphabet will move. 1, 2, 3, 4, 5, 1s. So obviously 1s means it will have no impact on the other, so it will be into 5 factorial. If we have 2s, so now repetition of 2s is there. 5c3 into 5 factorial divided by 2 factorial because of the repetition of 2s. Then we have 1, 2, 3, 4, 5, s, 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 5c2 into 5 factorial upon 3 factorial, repetition of 3s. So in the end, what we understand is that we will end up having the answers. So it is 120, it is 120, 600, 600 and 200. So the answer is 1520. So this was the case about the code generation. This was case number 7, lecture number 6.